roll around the string like this, right? So can you explain the source of the standing wave that's about over 30 hertz?
Over 30 hertz?
So can you explain the source of standing waves in your motions? In the
when we build the dread,
yes.
Since there is a tension, as I said in my definition of the dread, so there is a tension, the dread would be oscillating when we build the motor.
Why?
Why? Because tension is enough to make the dread to vibrate.
So you're saying that if there's a string with tension on it, and you just push it around, it doesn't vibrate. It vibrates.
Yeah.
So the reporter is saying that a situation in which I just let the string go, and that motion created a standing wave, and when I just drew the string, if there's enough tension on the string, the reporter is saying that the situation is analogous. Is that correct?
Yes.
And so, if there is actually tension on...
can I clarify about the second point?
Okay, so the source of standing waves is something vibrating, and
yeah.
You argue if there's tension...
When we build the dread, the air would be vibrating around, so there will be a drag force due to the air vibration.
So my question is, what actually causes the vibrating of the string?
Vibrating of the string?
Yes.
The rolling motion of the string, I think.
So if that causes the vibrating of the string, you're saying if I roll this around, if I hear something like 600 hertz sound, I'm rolling the string around at 600 hertz.
If you roll the dread at a fast enough velocity, it will be possible.
Okay, moving on to my next point. So you mentioned airflow separation, and can you tell me why airflow separation occurs in this problem?
Sorry for...
Can you just briefly mention why airflow occurs?
So when at the region where the ball is present, there is a low pressure, and at the back and the front of the ball would be the high pressure region. So when the air flows go over the ball, the drag force of the drag force which moves through the high pressure region to the low pressure region would result the direction of the airflow.
So if there's an ideal gas with no viscosity, would that still produce that vortex shedding?
I do not consider the viscosity as an important factor in making the air drag separation.
The fact is, what causes those vibrations actually, what causes those vortices actually, system friction between the air pressure and air flow and the cylinder, and that's why velocity significantly decreases near that region, and that's why air flow separation occurs. If that was taken into consideration, it would be much better. And now, so you see that the Straw's law is a function of velocity, right?
Yes.
And if you think about infinitely small cylinders, and if you divide thread into infinitely small cylinders, that's going to provide different frequencies
yes.
across moving at different velocities. Now, did you consider how the combination of those waves are going to be done and captured on the microphone to be a dominant frequency?
But what combination of the waves?
So
from the different part of the string,
yes.
Because it has a different angular velocity.
Different frequencies.
So, as you said, there will be a different velocity for each section, and for each section, the quantum vortex will be occurred.
Yes.
So by using the equations for the vortex shedding frequency, we could get the range for where the resonance could be occurred between the quantum vortex and the standing wave.
So tell me why these spectrum of all these waves are going to be. Tell me how these spectrum of all these waves are going to be combined to make a dominant resonance. How?
Dominant resonance. So the sound from the dread and the loss of source will be combined, and from this, at the point where the resonance would occur between the vortex and the standing wave, would have a highest peak and would be the main frequency.
Okay, Okay, moving on to experimentation points. Now, first of all, you chose to roll the string around horizontally. Is there any reason for that? Is there any reason for your
horizontal to give an equal force of the gravitational force
yes
acting on the system?
Yeah, so that's the point. There is gravitational force, and the measurement of the radius that you've done is so in order to measure the velocity of the ball, simply times the radius of the world motion times the angular velocity. Right? So what you're actually going to see is that because of the effect of gravity, the motion of the string is actually tilted. Like this.
Yeah.
So what value did it use?
But we assumed in our experiment that the ball and the thread is doing exactly the horizontal motion, not tilted.
So your possible error in your experimentation could have occurred.
Yeah, that could be error from this reality.
Your measurement was this, or about the actual value that should have been inputted is
Yeah.
Moving on to the next point. Now, how did you control the radius? And the question is asked because
Radius of the circular motion.
Yes.
We just controlled it as
By using the same
length of the string.
So what we're actually going to see in this motion is because the centripetal force that the motor can provide is limited. If the angular velocity increases, the radius is actually going to decrease because there's a limit on the centripetal force that the motor can provide. And
Why the radius of the string has decreased?
The radius of the string hasn't decreased according to different negative indices. Is that correct? Next question is, the amplitude of sound is also going to be greatly inaccurate due to the effect of gravity. So you measured the amplitude of sound and you put the microphone right here, right?
What is
This is the rolling motion, it's the microphone that your experience up.
Yes.
So what we're going to... Yeah, so what we're actually going to see is because the centrifugal force on this ball increases, as the angular velocity increases, this
But you draw the picture as the thread is tilted around? Tilted?
Yes.
I said that as in our experiment we assumed that the ball and the thread are not tilted.
Some more errors than approximation. So as the angular velocity increases, there's the effect of gravity and the centrifugal force. So as this value increases, the direction of this tilting motion will increase as well. And this distance between the microphone and the unit cylinders here, I think that will prove to be a great error in your experimentation. So your distance factor was not exactly controlled according to the angular velocity.
But
Since you assume that it's as a horizontal motion,
since you build the thread at a very fast velocity, as we said, there will be not much distance from the horizontal motion. So we assume that there will be no much tilted of the thread.
Okay, so finally, what was your sampling rate?
Sorry for not mentioning the sampling rate. The sampling rate for my FMT is for over 3 million.
Over 3 million
3 million?
Is this your sampling?
No. Oh, skip 1 0. Sorry.
Okay, this is your sampling.
Yeah.
Okay. And the exercise was, when I saw the presentation, about the same value. Something like this. 3, 7, 4, 3, 2. Can you justify your choice for using this particular FFT size?
We increase the sampling rate, the FFT size, it would show more accurate and more sophisticated rates of the frequencies. So we chose the high values of sampling rate.
And finally, what were the ratings numbers
very much.
I would like to finish my refutation.
Please take a minute to summarize.
Yes. So first, thank you for the reporter team for your wonderful effort, your wonderful research about problem number 2, kiting the error. And I would like to say that I went through many cognitive conflicts while solving this problem as well. So it's really nice to meet someone who studied my own problem. I mean, the problem that I studied as well. So we do get the factors that they identified as the source of sound. However, first we think their argument about standing waves don't make sense at all, because in order for this wave to vibrate, you're gonna need an initial force for that wave to vibrate, and that consequent vibration of the string is what's providing the standing wave. However, we don't see that there. As she stated, if we whirl this around with 600 hertz, we can actually hear the sound that's with 600 hertz. But that's not going to happen, ladies and gentlemen. And overall, we saw a lack of experimentation and fundamental concepts. However, thank you very much for presenting your own presentation regarding this issue. I was very touched. Thank you.
Please feel free to ask questions to both the reporter and the opponent. Mike to the reviewer, please. Reporter, can you? Please restart this time.
Okay. Thank you for both reporter and the opposing team, and for the passionate debate. And I want to ask some questions to both of you. And first for the reporter, in your experimental measurement, did you record the sound only caused by the motor, because as the motor rotates?
We remove the sound from the motor using the FFT. The FFT is a method of decomposing the sequence of the sound into different frequencies. So using the FFT, we could separate the sound made from the motor to the sound we want to see.
Okay. In addition, then, did you calibrate your frequencies, as, for example, using the tuning fork before you measured it? So before measuring the frequency, it is essential to calibrate the measurement. For example, using the tuning fork. So did you did that process?
So tuning fork.
So I'm asking that did you calibrate the frequency measuring the frequency? Did you calibrate the microphone?
So I don't know what's the exact meaning of the calibrate. Could you elaborate on that point?
Okay, I'll just pass it. And for the next question, so how many trials were done for each experiment?
We measured each sound for 30 times, and we find the average value for each trial.
Okay, thank you. And isn't there so then let's move on to the question for the opponents. So when you're talking about control of the radius, you talked about as the angular velocity decrease, then the radius also decrease. Can you explain more about it?
Angular velocity increases, centrifugal force increases, and because the motor has a limit on the centrifugal force, as weight decreases, the R is going to increase.
So I cannot understand that part, because as there is the radius of the rotation is the length of the string, and it is constant. How can?
No, in that case, what you're actually going to see is that the string whirls around the motor in order to fit that centripetal force, the limited centripetal force that the motor can provide. So this motion occurs by the string rolling around the motor and getting the radius shorter. That's why radius can't be controlled under experimentation.
And in addition, you also pointed out the distance between the microphone and the thread. So could you explain more about that?
I think it's time.
Thank you for the answer.
You want to give a short answer for that question?
If you can, please. So you pointed out the problems in distance between the thread and the microphone, and if you please could explain more about it.
So you get the fact that as angular velocity increases, the frequency, the sound source that is the string is going to increase, right? So because amplitude is a factor that's very largely influenced by the distance between the sound source and the sound detector, that's going to cause a significant difference, and that's not controlled in our experimentation.
Okay, thank you for the answer.
Okay, reviewer, you have 2 minutes to prepare. Okay, the reviewer has the floor. Please start the time.
Hello, my name is Ha-Kyung Kim. I'm a member of the Team Mighty of Korean Science Academy, and I'll review the problem number 2, cutting the air. So first, to begin with, I want to start by suggesting some points to both teams. First, this is the reinforcement that I can suggest for the presentation. First, they lack the convincing variation of the parameters to show their argument, and they only control the variables, and there is a more, and then they did not actually defend the accuracy of their experimental setup, and there's kind of invalid data measurement. Also, this is the reinforcement for the refutation, so they need more clarity in questioning during the discussion. And then let's move on to the flow of the discussion. First, opponent asked them why they used the theoretical approach to the straw Hall's number, and the reporter said that it is used to explain the parameters and relate it to the generation of the sound. And the opponent then asked the cause of the sending waves and why does the sending waves are made, and it was the good, and this point was well pointed out because it is related to the question. And however, at this question, the reporter gave the insufficient answer that the tension makes the sending wave. And also, opponent asked how the combination of the waves makes the dominant. And the reporter well answered that the points of the resonance, as the points of the resonance of the harmonic frequency is equivalent to the vortex frequency, then and that's the frequency that dominates the distinct sounds. And also, opponents pointed out the measurement of the radius and the, for the effect of the gravity, and the reporter says that they made appropriate measurement. So this is a further discussion that the opponents asked about the control of the radius, so asking about can it be the error source of the vertical tilt. The reporter answered that they assume that it's horizontal, and opponent also asked about the sampling rate and can you justify it. And the reporter answered that the 30,000 times is appropriate for their measurement. So, although despite of the passionate debate, I want to suggest more points for to improve the improvement. So about the calibration. So I want to talk about the tension part. So in the experiment, the reporter team used the styrofoam ball which has the small mass, which means that we cannot neglect the effect of the density of the string. As such, we should also consider the and if we consider the density of the mass, we cannot neglect that the tension distribution is different along the thread. And for the distinct noise, they will talk about the descending wave is distinct, and the Karman vortex effect makes the additional sound, which I also agree. And I think it would be better if they talk about the shape of the thread, as according to the condition of the Karman vortex thread effect, the helical shape of the thread decreases the Karman vortex thread effect. So if they had, thank you for listening while review.
Thank you for the opponents and the review teams for pointing out some disappointment in my presentation, and I want to clarify some points about my presentation. The first question about the opponent's team was that how the thread is doing the vibration motion. So I want to clarify on this point.